Simple interest. Introduction. When money is borrowed, extra money is paid to the lender for the use of the borrowed money for a given period of time at a given rate. The extra money paid is called interest. When money is lent or borrowed on simple interest, interest is calculated every year. The money borrowed or lent is called the principal. The sum of the principal and the interest is called the amount. The rate at which interest is calculated is called the rate of interest per annum. If P is the principal, T is the time in years for which the principal is deposited or lent, and R is the percentage rate of interest charged or paid, as the case may be, per annum, then the interest I is given by I is equal to PTR upon 100. The amount A is given as A is equal to P plus I. Example 1. Calculate the simple interest on Rs 1000 for 4 years at the rate of 6% per annum. Solution. P is equal to Rs 1000, T is equal to 4 years, and R is equal to 6% per annum. SI is equal to PTR upon 100. This is equal to 1000 into 4 into 6 divided by 100 is equal to Rs 240. Example 2. What principal will earn an interest of Rs 576 at 6% per annum in 3 years? Solution. I is equal to Rs 576, R is equal to 6% per annum, T is equal to 3 years. We know I is equal to PTR upon 100. This implies that 576 is equal to P into 3 into 6 upon 100, which implies 576 into 100 upon 18 is equal to P. This implies that P is equal to Rs 3200. Difference between simple and compound interest. Simple interest SI on a certain principal P at a certain rate R for a given time period T, SI is given by the formula SI is equal to P into R into T upon 100. In our daily life, the interest charged or paid is not simple interest. The interest charged or paid by the banks, post offices, insurance corporations or finance companies is not the simple interest but compound interest. In these cases, the interest which is due after a certain period of time is reinvested to earn further interest. This means the amount after the first time period becomes the principal for the second time period. This process can be repeated for a number of time periods. The difference between the original principal and the amount in the end of the last time period is known as the compound interest on the original principal for that time period. Example 1. Find the total amount due on Rs 8,000 for 3 years at the rate of 8% per annum interest compounded annually. Solution. 1. Let P1 denote the principal for the first year. R is equal to 8% per annum. T is equal to 1 year. First time period. The interest at the end of first year is given by I1 is equal to Rs 8,000 into 1 into 8 upon 100 is equal to Rs 640. Amount at the end of the first year. A1 is equal to Rs 8,000 plus Rs 640 is equal to Rs 8,640. 2. The principal at the beginning of the second year is equal to P2 is equal to Rs 8,640. I2 be the interest at the end of the second year. This is equal to Rs 8,640 into 1 into 8 upon 100. This is equal to Rs 69,120 upon 100 is equal to Rs 691.20. Amount at the end of the second year, A2 is equal to P2 plus I2 is equal to rupees 8,640 plus rupees 691.20 is equal to rupees 9,331.20 is equal to P3. Principal at the beginning of the third year. 3. Now, P3 is equal to rupees 9,331.20. I3 be the interest at the end of the third year is equal to rupees 9,331.20 into 1 into 8 upon 100 is equal to rupees 74,649.60 upon 100 is equal to rupees 746.4960, which is approximately equal to rupees 746.50. Amount at the end of the third year is equal to rupees 9,331.20 plus rupees 746.50 is equal to rupees 10,077.70. Compound interest is equal to rupees 10,077.70 minus rupees 8,000 is equal to rupees 2,077.70. Example 2. Find the amount on compound interest, a sum of rupees 5,000 for 2 years at the rate of 2% per annum. Solution. P1 is equal to rupees 5,000. R is equal to 2% per annum. T is equal to 1 year. I1 is equal to rupees 5,000 into 2 into 1 upon 100 is equal to rupees 100. A1 is equal to P1 plus I1 is equal to rupees 5,000 plus rupees 100 is equal to rupees 5,100 is equal to P2. Now P2 is equal to rupees 5,100. R is equals to 2% per annum. T is equal to 1 year. I2 is equal to rupees 5,100 into 2 into 1 upon 100 is equal to rupees 102. A2 is equal to P2 plus I2 is equal to rupees 5,100 plus rupees 102 is equal to rupees 5,202. Thus, amount at the end of the second year is equal to rupees 5,202 and compound interest is equal to A minus P is equal to rupees 5,202 minus rupees 5,000 is equal to rupees 202. Deducing a formula for the compound interest using simple interest and changing principal. A is equal to P into, in the brackets, 1 plus R upon 100, the whole raised to the power n, where A is equal to amount, P is equal to principal, R is equal to rate of interest per annum, N is equal to number of conversion periods, that is, number of times the interest is calculated. Since I is equal to A minus P, so CI is equal to A minus P is equal to P into, in the brackets 1 plus R upon 100 the whole raised to the power n minus P is equal to, in the curly brackets, P into, in the brackets 1 plus R upon 100 the whole raised to the power n minus 1, curly brackets closed. Example 1. Calculate the compound interest and amount by using the formula if interest is compounded annually. Principal is equal to rupees 16,000, time is equal to 2 years, rate is equal to 8% per annum. Solution. P is equal to rupees 16,000, R is equal to 8%, time N is equal to 2 years. Therefore, amount P is equal to, in the brackets 1 plus R upon 100, the whole raised to the power N is equal to rupees 16,000 into, in the brackets 1 plus 8 upon 100, the whole square is equal to rupees 16,000 into, in the brackets 1 plus 2 upon 25 the whole square is equal to rupees 16,000 into 27 upon 25 the whole square. This is equal to rupees 16,000 into 729 upon 625 is equal to rupees 18,662.40. Since CI is equal to A minus P, therefore CI is equal to rupees 18,662.40 minus 16,000 is equal to rupees 2,662.40. Growth and depreciation. Example 1. In a laboratory, the count of bacteria in a certain experiment was increasing at the rate of 2.5% per hour. Find the bacteria at the end of 2 hours if the count was initially 5,06,000. Solution. Let the initial count of bacteria be P0. This implies that P0 is equal to 5,06,000, R% is equal to 2.5%, T is equal to 2 hours, P1 is equal to count of bacteria after 2 hours.
Is equal to 5,06,000 1 plus 2.5 by 100 whole square
is equal to 5,06,000 into, in the brackets 1 plus 1 upon 40 the whole square is equal to 5,06,000 into 41 upon 40 into 41 upon 40 is equal to 12,650 into 41 into 41 upon 4. This is equal to 5,31,616.25. This is equal to 5,31,616 as number of bacteria cannot be in decimals.